Okay, so in this question, we've got two parts, A and B. Okay, part A is basically work out the frequencies, okay, natural frequency and the damped natural frequency, in radians per second and in hertz. Okay, so if I go to A. Okay, so omega naught is root k upon m. K is 1000, m is 10, so that's root 100, which is going to be 10 radians per second. Okay. And then the equation for omega d was given omega naught squared minus gamma squared upon 4. Okay, that's in the equation up here. Now gamma is c upon m. So it's 20 divided by 10, which is 2. Okay, so in this equation, omega squared is 100 minus 2 upon, that's 4, isn't it? 2 upon 4. Okay, if we do that sum, two squared is 4, sorry. So that's 99, root 99. So 9.94. 95. Okay, so in hertz we've got F naught, which is omega naught divided by 2 pi. So that's 10 divided by 2 pi. 1.5915 hertz. And FD is going to be omega d divided by 2 pi. So if I drop that. .5836 hertz. Okay, so those are the solutions to these equations for part A. Okay, for part B, we've been given an initial velocity of 2 meters per second, and it's set in motion by that velocity. Okay, so from that we can work out what our initial conditions are. X of 0, which is our displacement, is 0, and x dot of 0 is 2 meters per second. Okay, so there are our initial conditions. So we've got two initial conditions, and we've got in our equation, which is this is what we've got to try and find, we've got two unknowns, A and alpha. Okay, so we need two equations to solve those two unknowns. Since we've got two initial conditions, we can find those two equations. So the first equation is the displacement. Okay, I'm just rewriting what's up there above. Okay, there's our equation, two unknowns A and alpha. If we apply our initial condition, x of 0, we've got A, okay, e to the 0 is 1, so we don't need to worry about that. We have cosine of alpha equals 0. Now A can't be 0 because that's the amplitude, okay? If A is 0, then it's not oscillating. This thing's going to be oscillating. So cosine of alpha must be 0 equals 0. So alpha must therefore be pi by 2, okay? So if you want to write that as a decimal, 1.5708, okay? Radians. Oops. Radians. Okay, so we know alpha now. We need to work out what A is. But to work out what A is, we need to come up with an equation for x dot of t, okay? Now, we did that in the lecture, okay? If you remember, it was A, E minus gamma upon 2t, okay? Minus omega d sine omega d t plus alpha minus gamma upon 2 cosine omega d t plus alpha. Okay, that's what we came up with in the lecture. And so we did then find x dot of 0. That's to be a, e to the 0, 0, minus omega d sine of alpha, okay, minus gamma upon 2 cosine of alpha, okay. We already know that cosine of alpha is 0, okay, so we can get rid of that, okay. And so we've got, and we know that this equals 2, okay. So we can say that we've got minus a omega d sine of pi by 2 equals 2. Okay, what's sine of pi by 2? 1. Okay, so we've got a equals 2 divided by minus omega d. And if you do that sum, okay, so there's our value for A. So our equation of motion, x of t, is minus 0.201 e to the minus t, because gamma is 2, divided by 2 you get 1, okay, cosine of 9.95 t plus 1.5708, okay, and there's our solution. Okay, so that's how you work it out. Basically, when you've got a free oscillation, you need to apply your initial conditions to get those unknowns.